distribution test, physical values test, and Spearman rank calculation. Univariate analysis means study one variable at a time. For example, marks of students in statistics. That means particular subject only handle at a time. So this type of variable handlings and the univariate analysis is helpful. So the univariate analysis and also bivariate analysis, multivariate analysis. So three types of analysis here. Univariate analysis only handle about one variable at a time, but bivariate analysis means two variables handling at a time, and also multivariate analysis means two or more variables handling at a time is called as a multivariate analysis. Univariate analysis focuses on analyzing one variable at a time. Its main purpose is to understand and summarize data clearly. So data captured clearly through univariate analysis at a time, one variable. Use one variable at a time. Then next one. For example, mark analysis 40, 50, 60, 70, 80. So mean, median and also mode captured through univariate analysis. For example, 40, 50, 60, 70, 80, the mean is captured through 40 plus 50 plus 60 plus 70 plus 80 is divided by total number of marks and that means divided by 5. The mean value is 60. So it is used to summarize the performance. So that value is also that also values displayed through charts. The next one is Z-test explanation. So Z-test is mainly used for handling large type of samples, but T-test only used for handling small type of samples. So the Z-test and also T-test comes under the parametric test. Z-test, T-test and ANOVA test. So the three tests comes under the parametric test. For example, company checks average salary versus standard salary. Average salary means total number of employees salaries earned divided by the total members total number of employees. So equal to average salary. But standard salary means the company already fixed the salary. For example, executive salary is 25,000 per month. Manager salary for 50,000 per month. It is already the norms and procedures, the rules are already fixed by the companies. So that is called as a standard salary. So the company checks average salary versus standard salary. It mainly checks for the improvement, any improvement arises or decreases. So the Z-test is useful for this purpose. The Z-test is a statistical test used to make decisions about a population used on sample data. So used for population based on a sample data. Statistical test used to make decisions. So it is used for decide which one is good or any improvement arises or decreases for the company or for an educational institution. That decision is made through the Z-test. It is a population mean. It is also my example mean. Population means is a total mean, but sample mean is a captured one from the population mean. So the population mean is 5 types of subjects, 5 types of subject marks earned through the students is a population mean. But the sample mean is captured for a maths or science for any one subject take from the population mean, and also class and also captured for the mean of the particular subject is also called as a sample mean. So next one is t-test. So used for small samples. For example, compare marks before and after training. So, for example, placement training go through the students. After checks, so before check the students, before the students get the employment opportunities through the campus. Before we conduct the placement training, and also after we conducting the placement training, the students improvement from that particular placement. So the T-test is useful for compare both before and also after improvement for particular data. Then next. The T-test is used to determine whether there is a significant difference between, means when the sample size is not, and also the population standard deviation is no. Then next.
Not known,
I will correct it. So paired T-test, the paired T-test means we capture only one subject, pre and also post, compare both the marks for the particular subject only. That are also called as a paired T-test. So the T-test is classified into paired sample T-test and also one sample T-test. Okay, the next one. Before and after versus after training. Already we seen about that. The next one. Non-parametric test. The parametric test is a type of statistical test that makes assumptions about the parameters of the population distribution. So already assumptions I have, and also the distribution is equally distributed or normally distributed. We get a bell-shaped curve, that is called as a parametric test. But non-parametric test is conducted for the situation is the data is abnormally distributed. That means not a normal distribution. That situation only we used for the non-parametric test. For example, customer satisfaction level for a particular product. For a particular product, the customer satisfaction level is also maybe left skewed or right skewed. That means the customer satisfaction may be increased or decreased at a situation or their mindset also. So many conditions, many situations determined about the customer satisfaction level. So this situation, the non-parametric test is very useful for conducting the test and also capture the result. The next one. Purpose, non-parametric tests are used when data does not follow normal distribution or when data is quantitative, non-numerical. So the normal distribution so non-parametric test is used when the abnormal distribution is arises. So when abnormal distribution arises, the non-parametric test is used. Next. Types of non-parametric test. Non-parametric test is classified into chi-square test, Mann-Whitney U test, Wallace test, Driscoll-Wallace test, Spearman's rank correlation, etc. So the chi-square test is a statistical test used to examine whether there is a significant association between categorical variables. Categorical variables means female category or a male category or a students comes under social science groups. So for a particular categorical data used for the distribution, in this case the chi-square test is used. For example, test relation between gender and also product choice. The next one. Mann-Whitney U test. This Mann-Whitney U test is useful for compare satisfaction between two group of people. So two group of people also having a same taste or also same thoughts. So this but some differences arises between the two groups. we conclude the similarities are that there are some differences we capture through the Mann-Whitney unit test. Then next one. Wilcoxon test. Compare before and after without normal assumption. So in this case, we haven't any assumptions, but we capture from before result and also after result. For example, already we seen the training conducted to the students. So before conducting the training, the result of the students, and also after we conduct the placement training, the students' result also captured, and then pre and post results also compared through the Wilcoxon test. Then next.
Madam, I don't want this kind of a performance. I made it very, very clear to each and every one. I don't want describing what is what. The objective is the people who are coming for presentation are supposed to share the data. All of you must bring their laptop and you need to demonstrate what are the analysis, how do you interpret the data. That is the thing. It is not what is what. No, you are not an undergraduate student. You who are sitting here are not undergraduate students, are not even PhD. They are the scholars and they want to know where and how I can use the data and use these statistical techniques. How do I interpret the statistical techniques? How do I interpret the result comes out of this particular thing? So Wilcoxon, where the Wilcoxon test can be used, where the Mann-Whitney can be used, and this is the data. And with this data, I know when we work with the SPSS, the output format is like this. And when it comes significance, and how do I interpret the result? This is what I want. Otherwise, this is not at all the objective of the research part.
Sorry, sir, I will answer.
I don't want. Wilcoxon example, compare before after without normal assumption. Okay. Say for instance here, you have a t-test before and after, and here also before and after. What is the difference between the t-test of before and after? I want to use the name of the test. T-test I am using, but I don't want to go specifically. And here also you are talking about the before and after. What is the difference between these?
This comes under the parametric test, sir.
That everyone knows. Parametric and non-parametric, everyone knows. If they are not knowing, that is ignorant. It is a complete ignorance of the scholars. And you cannot know. In that case, I will accept the present reports. Because you cannot break everyone. Okay, they must also come. And Princey and other people are in there. So it is not the last day before 1 hour and then sending it to the people. It should be before at least 3-4 days before the topic needs to be.
Sir, the topic already shared, sir.
Already shared, but the announcement also need to go at least 2-3 days before. And that's number one. Okay, that is the second point is when you are now coming for a presentation, each one need to share the data. That's a mandate. Where you will get the data, all those things, that is not my issue. Even if you want to use your own cooked data, I'm okay. The thing is here, you need to give a demo, take the result, analyze the result, and you need to give, this is the way in which you need to give interpretation. But is it happening? For the last 2 things, it's not happening. I told when who have given the presentation, Sanjay, Shivashankar given a presentation, I told very clear, this is what we want. Making the people to learn. It is not simply sitting like IPL match and watching, okay, something is happening there. Sanjay Samson did the second ball, third ball, got out. That is not our thing. I think we must learn. Okay, so how do we learn? When you work on the data and you are getting the result, and this is the way in which I interpret the result, that's the learning. And these things you will never ever forget. So when and people who are really want to apply those techniques, they can apply in their thesis or apply in their research papers. Now, is it this kind of a thing serves our purpose? Definitely not. Yes.
Crystal values just compare more than two views of performance.
Here also, crystal bodies vis-a-vis ANOVA. What is the difference between crystal bodies and ANOVA? Crystal body is non-parametric. And people always say that this crystal body is non-parametric, whereas ANOVA is a parametric. That is not the purpose. The purpose is crystal bodies, what is the data? Okay, download the data. You look at the data from, say, books like statistics for management, level and routing. So look at that. Say you can have that kind of. No, that's what the problem with many of the scholars are. You are not able to come out. So you need to read those kind of books. No one will give you this kind of. You need to go and then read carefully the Levinas routine. How many of you just touched even that book? Tell me. Anyone know that there is a Levinas routine statistics for management? Except the movie. Anyone know? Anyone seen that book? It's like a pillow. Big one. The data they normally give the small data set. So when you take the data set, enter it in Excel or SPSS, then you perform the analysis, then you will know, okay, I learned something. Right? So crystal bodies, crystal values is a non-parametric, ANOVA is a parametric, compare two groups. Correct? But how do I understand without performing the tool? How do I understand the difference? That's number one, as I said. Number two, if I get a result, then I need to interpret. Right? How do I interpret the result? That is also not given, right? That's the problem.